Okay, so 4.5 is on substitution. Okay, how do we use substitution? Okay, so for f of u of x, okay, we say that the integral for f of u of x, okay, make sure you say the x because you don't want to go around saying f of u. People, that's offensive to some people. So, you have a question already? Okay, what's your question, Gabriel? And yes, I already did buy my Christmas presents for my
When you're doing f of x minus g of x, g of x is the would be the the graph that's above the area that you're fighting.
f of x minus g of x.
Yeah.
Okay. Again, think of it like this is f of x. That's the area below f of x. Say that this guy is g of x. So that's minus this area below g of x. So what's the area that I really want? Right? It's kind of like, think about how would you get the area of a donut?
Or I mean, what I mean is, the when you get the two equations, the f of x would always be the line above g of x. That's how you would determine the what which graph would be f which function.
Between 2 points, because they may change. I mean, it may be like that, right? And you don't know which ones, but you know in the interval, you know, in an interval, right? You'd say, well, between say -1 and 2, this one's below and this one's above, but from 2 to 4, the reverse is true, right? So just know that the one on the top comes first and the one on the bottom comes second. You don't have to label them f of x, g of x. It's two functions. The one that's
Got it.
is the positive and the one that's below is the negative. And then you just add them. Okay. So hopefully that helps there. Does that answer your question?
Yes, it does.
Okay. Okay. So we've got f of u of x. Okay. Okay. And then what do we need here? We need the u prime of x. Why? Why do we need a u prime of x? Because we're undoing the chain rule. Okay. We're undoing the chain rule. So what we're doing, we're undo the chain rule. And so you need a u prime of x. Okay, this is called my integration factor. Okay, so my u prime of x dx is called my integration factor. And I can't integrate without it. I can't integrate without having my integration factor. Okay, because remember when we take a derivative of f of u of x, okay, we end up with f prime of u of x, okay, times u prime of x dx. So if I want to go backwards, okay, if I want to go backwards, okay, I need that integration factor. Okay, so, and this thing is equal to, I should make this a capital here. If I make this a capital F, then I can imply that little f is the derivative of capital F, or capital F is the antiderivative. Okay, So, but we need to have my integration factor, and this is going to equal f of u of x plus c. Remember the plus c? Always plus c. Always plus c. Okay, always plus c. Okay, but the goal today is to find out, well, what's my u prime of x? And there's a systematic way to figure out what the u prime of x is so that we can integrate. Okay, so for example, okay, what if we had, say, what I want. Let's do x minus 7 or 2x minus 7 squared, right? What would be the derivative of this? Let's take the derivative of this thing. And that would be 2 times 2x minus 7 raised to the first power, right? That's the derivative, right? Okay. So that, maybe we'll make this to the third power. That'll make it better. I don't want it to the first power because I don't want it to just go away. Let's do 3 here. Okay. So this is going to be 3 squared. Okay. But then I would have to do the derivative of the inside, my u prime of x, and I would get 2. Okay. This is my extra 2 from the chain rule. Okay, maybe I'll highlight that. This is my extra 2 from the chain rule. Okay. So I can't integrate this thing without that extra 2. If I were to integrate this thing and leave off that extra 2, they're not going to be equal to each other. Okay. For example, if I did this, if I took the integral of 3 times 2x minus 7 squared, okay, but I left off the 2, then I'm not going to get the correct answer. Okay, I wouldn't be able to go back to this guy. Okay, and why is that? Well, okay, because when we take the derivative, we end up with an extra 2. Well, how do we allow for that extra 2? Okay, how do we allow for the extra 2 here? Okay, so say that, right, so they say this is, I'm just going to let this be equal to 6 times 2x minus 7 squared. Okay, so now let me show you how we integrate this thing. Okay, oh, sorry, that's a 6. Okay, and we get the right answer. We get back here. Okay, here's what we do. Okay, we could split off a 2 if we wanted to, but that's kind of like thinking, well, how do we know that there's a 2? Well, there's a 2 inside here. And what we do is we do something called a U substitution. So U substitution. And the U substitution is what this thing is. That's my U of x. Okay, the inside. So I'm going to let U of x equal, okay, equal the 2x minus 7. I'm going to let U of x equal the 2. I'm going to tell myself, okay, the U of x in this problem, the inside is 2x minus 7. Now what I'm going to do is I'm going to take the derivative of this to see what happens, what occurred, what popped out if I had taken the derivative. What would be the product of doing the chain rule on this inside function? Well, I would say that du, take the derivative of this thing, is equal to, or u prime, well, maybe we'll do u prime, okay, u prime of x, okay, is equal to 2. And then I say, well, this is 2 dx. Okay, and now notice that I have my 2 taken into account. Okay, so u prime is equal to 2 dx. Well, this guy up here doesn't have a 2 dx, it has a 6. So what I do here is I do this. I divide by 2. Okay, I divide by 2. Okay, divide by 2. And I call this thing du over 2 is equal to dx. So now I do something and I substitute. Okay, I do something tricky here. And I say, I'm going to substitute this. And wherever there was a 2 minus x, 2x minus 7, okay, wherever there was a 2x minus 7, I'm going to make that u. So this is 6u squared. And wherever there was a dx, I'm going to replace that with du over 2. So this is going to be du over 2. Okay, taking into account that if I took the derivative, I would have had to multiply by 2. Taking the integral, I'm going to have to divide by 2. So to undo that, taking the derivative, I would have had to multiply by 2. Taking the derivative, taking the integral, I would have to divide by 2. So this takes into account that, oh yeah, I have to divide by 2. Okay, so we're going to get, now let's divide. 6 divided by 2 is 3. Okay, 3u squared. Okay, so now how would I integrate 3u squared? I just did a change of variable here. 3u squared, well, that's going to be 3u cubed over 3. Those are going to cancel. Okay, and I get u cubed plus c, but I have to now go back to my original variable, which was x. And what was u in this case? U was 2x minus 7. And so I go 2x minus 7 cubed plus c. And that would give me back to my original answer. We don't know what the constant was. In our original, the constant was 0. Okay, but we didn't know that. We have to take into account that there could have been a constant there, that when we took the derivative of that, it just went away. Okay, so this is called u substitution, or u sub. Okay, u substitution. So we're identifying what is the u, we're getting the u prime, and then we're dividing by that u prime. Okay, so it's a hard concept conceptually, but the math is actually pretty straightforward. Okay, let's do an example here. Example 1. Okay, let's integrate 2e to the x squared dx. 2e to the x squared dx. Okay, so what's u going to be? What's my u of x? If I were to have to take the derivative, what would be my inside function? Well, how about the x squared? Right? Okay. The outside function is the e. Okay, so this is the outside function. The inside function is the x squared. Okay. So u is going to be, because we eventually want this to be what? We want this to be 2e to the u du, because then I can integrate easy peasy, because the integral of e to the u is just e to the u. That's easy. Okay, but I have to take into account that this thing is not just, it's not just that. Okay, so what's du? Du is equal to, okay, oh, this was a 2x, sorry. Okay, this was du is equal to 2x, okay, dx. And so, okay, so we have, I'm going to rewrite this. We have the integral of 2x e to the x squared dx. Okay, so what was u? U is equal to x squared. Okay, so this is going to be, I'm going to rewrite this, e to the x squared times 2x dx. And there's a reason that I'm doing that. Okay, because what's x squared? That's just u. So this is e to the u. And what's 2x dx? Well, the 2x dx, that's just du. Look at that. Okay, this was my du from up here. Okay, x squared, when x squared is u, when u is equal to x squared, then the dx is 2u. So I have the u prime dx. And so I could integrate. Okay, so now we're going to take the integral of this thing, which is just e to the u plus c, because the integral of e to the u is just e to the u. And then, well, what is u? Let's sub back in what our u was. Well, we defined u as x squared. So this is just e to the x squared plus c. That's our integral. Okay, let's try another one here. Okay, number 2, we have 3x squared times x cubed plus 1 to the 10th power dx. Okay, so what's the u in this case? What's the u? Is the u the x squared, or is the u the x cubed plus 1? Well, we have to kind of think ahead on this one, because we have to think, can I get an x cubed? If I take the derivative of the inside x cubed, can that give me an x squared? Or what happens if I take the derivative of an x squared? I just get an x. So I'm going to go with the x cubed plus 1 because I would end up with an x squared when I took the derivative of an x cubed. I always go down 1 power when I take the derivative. And so I'm going to let this be x cubed plus 1. Du is equal to 3x squared dx. Look at that right here. This thing right here. That's my du. So this thing just becomes u to the 10th power. Why? Because we defined u as x cubed plus 1. And then du. Okay, our du is equal to this whole thing, which is combined in the initial problem. So now let's integrate this. Well, that's u to the 11th over 11 plus c. But what was u? Well, I'm going to make this 1/11 times u, which was x cubed plus 1 to the 11th power plus c. And you could see that if we took the derivative, we would get the same thing out. du is equal to u prime of x dx, which makes kind of sense because du is equal to, how could I rewrite u prime of x? That would be du dx. And look, the dx's cancel out. Okay. So that's a way to think about it. Okay, you don't have to know that. That's a little, that's just more technicality. Okay, what you really need to focus in on is, well, how do I manipulate the function, right? And again, if I took the derivative of this thing, what would I have to do? I'd have to do the derivative of the outside, which would be 1/11 times 11, right? Times x cubed plus 1 to the 10th. That c would go to 0. That would go to 0. And then I would be left with times 3x squared, right? Because that's the derivative of the inside. Derivative of the outside, derivative, the 11s would cancel, and I would be left with my original x cubed plus 1 to the 10th power, right? So if I took the derivative of this thing, this is d dx of 1/11 x cubed plus 1 to the 11th plus c, okay, would be equal to that. Okay, but the result that I'm looking for is just the integral. Okay, but you could prove, you could check your work by taking the derivative of this. Okay, you can always check your work by just taking the derivative of your answer and seeing, oh, do I get out, using the chain rule, do I get out what I initially put? Okay, let's try the next one here, number 3. Okay, the integral of 2x over 1 plus x squared dx. Okay, again, we have a choice here. Do we let the u be the top function, or do we let the u be the bottom function? Top function or the bottom function? Oh, let's think. What would happen if I took the derivative of 2x? I would get a 2, right? Well, what happens if I take the derivative of 1 plus x squared? I would get a 2x. Ah, okay. So I could even rewrite this as 1 over 1 plus x squared times 2x dx, anticipating that when I take a u of 1 plus x squared, I get a du of 2x dx. Look at that. That's nice. So what does this whole thing become when I do this u substitution? It becomes 1 over u du. Why? Because the du was equal to the 2x dx. The du is equal to the u prime dx. And so what is the integral of 1 over u? Does anybody remember what the integral of 1 over u is? Any ideas? Yeah, very good, Oscar. It's natural log, yes. Natural log, okay, of u, okay, plus c, okay, always plus c. Natural log of u plus c. And then we're going to do the natural log of 1 plus x squared, okay, plus c. I could drop the absolute value bars if I wanted because 1 plus x squared is always positive. You could put in parentheses or absolute value, it doesn't matter on this one. But we just can't take the natural log of a negative number. It's just we're not allowed. Okay, so just keep that in mind. Cannot take the natural log of a negative number. That's why we put the absolute value bars there. Okay, it just forces us to not take the natural log of a negative. Okay, but either way, it doesn't matter. Okay, I'll accept either of those. Okay. Okay, let's do a u sub, but we're going to use limits. We're going to do a definite integral this time. We're going to do a definite integral from 1 to 2, okay, of 2x over 1 plus x squared to the 5th power dx. Ooh, okay, spicy. Okay, so what's going to be my u in this case? What's going to be the u? Well, very similar to the last problem, right? Okay, so I'm going to let the 1 plus x squared be the u. And the du is equal to 2x dx. Okay. Nice, nice, nice. I mean, the other way you could think about this, and maybe this is what you were talking about, Oscar, is when you take the derivative of this, you get du dx is equal to 2x, right? And if you wanted to multiply both sides by dx, then du is equal to 2x dx. Okay, maybe that's how I should have explained it originally. Okay, so this is just the u prime is that. Okay, so du is equal to the 2x dx again. Okay, so this becomes, okay, 1 to 2 of 2x dx, that's the du, so that's fine. Then 1 over 1 plus x squared. What's the 1 plus x squared? That's u to the 5th power, and then this is just du. Okay, interesting. I'm going to integrate. Okay, I'm going to leave off the limits of integration until I sub back in for x. Okay, because these limits are not in terms of those limits were in terms of x, not u. Okay, but when I sub back in for x at the very end, I'll show you how we're going to deal with that. Okay, so how are we going to integrate this thing? 1 over u, I'll leave them there. 1 over u, well, I'm going to say that this is 1 to 2 of u to the negative 5th du. Okay, so now let's use the power rule to integrate this. Use the power rule. Okay, so I'm going to raise this up 1. I'm going to add 1 to this. So negative 5 plus 1 is negative 4, and then I'm going to divide by that number. Okay. Okay, and then normally I'd have a plus C here, but I don't, okay, because I'm going to have limits of integration. I'll put the 1 and 2 there. But I do not plug the 1 and 2 into U. Bad. Do not do that. Okay, do not. -4 over -4 minus 1 to the -4 over -4. This is bad. Okay, do not do this. Do not do this. It makes everyone sad. Okay. Boom. Okay, little tear right there. Okay, there's mega tears. Okay, there's like a puddle on the floor of tears. Okay, do not do that. Okay, what you need to do is you need to plug back in for your X. Okay, exactly. Okay, you need to plug back in for your X. What is the X? What was the original X value? I'm sorry, what was the original U? U was 1 plus X squared, right? 1 plus X squared. Okay, so this is 1 plus X squared to the -4th over -4, evaluated from 1 to 2. Okay, interesting. So what's this thing going to be? Well, I'm going to bring the -4 down below. Okay, -4th power. So this is really 1 over -4 times 1 plus X squared to the 4th power, evaluated from 1 to 2. Okay, and so now I can plug in my 2. Yay! There's much rejoicing. Okay, so this is 1 over -4 times 1 plus 2 squared minus, or to the 4th power, sorry. Okay, minus 1 over -4 times 1 plus 1 squared to the 4th power. Okay, so what's this going to be equal to? -4. 1 plus 2 squared, that's 4 plus 1 is 5. That's 5 to the 4th power. Okay. Minus, okay, 1 over -4 times 1 plus 1 is 2. This is 2 to the 4th power. Okay. Okay, so 5 to the 4th power, that's 625. You could just plug it into a calculator. This is -4 times 625. A minus here. I've got 2 minuses. See these 2 minuses? That's going to make a plus. Okay, and this is 4 times 16. 4 times 16. Okay, so this is 1 over -2500, I think. Yeah, 2500. Plus 1 over 4 times 16 is 64. Okay, common denominator here. Whew. Common denominator is actually 40,000. So -2500 times, okay, I know that that's at least divisible by 4. So let's see, 2500, yeah, is divisible by 4. So I'm going to multiply both top and bottom by 16. 16 here. Oops. 16. Okay, plus 1 over 64 times, I'm going to do a 625 here. 625. I think 64 times 625 is that 40,000, yeah. So I've got 16 over this, yeah. Yeah, -40,000 plus 625 over positive 40,000. Okay, that's good. Okay, and so the negative I can move on top if I really want to. I could put the negative up there if I want, but just know that it's 625 minus 16 over 40,000. And so what is 625 minus 16? 25 minus 16, that's what, 9? So I'm going to say 609. 609 over 40,000. Okay, and you could plug that into a calculator and get an approximate answer. Okay, so 609 divided by 40,000 is about 0.015225. Okay, so there you go. Nice. Okay, number, what do we have here? Oh, I didn't even label that one. We're at, well, we were at number 4. Okay, and so now we're going to do number 5. Okay. Okay, so I want to go integral. Okay. Okay, of 1 to 3. Okay. Okay, of natural log of 3x over x. Okay, natural log of 3x over x dx. Okay, let's try this one. Okay, what's going to be the u in this case? The u. Okay, let's try the u. Let's try 3x. Okay, try 3x. Now the u's, they don't always work out. Okay, try 3x. Okay, so if I say that u is equal to 3x, then du is equal to 3 dx. Okay, and so if I were to, I could divide by 3. And so I would get what? I would get the integral of 1, 2, 3, okay, over x. And then this would be natural log of u times du over 3. Okay, but I have this x here, this extra x. That's problematic. You're like, well, we could put x in terms of u, and yeah, we could divide. We could say x is equal to u over 3. So I could say, well, put u over 3 in there, which is going to cancel those out. And what did I do? I really didn't make the problem much nicer, right? It didn't really help me much. I went from a natural log 3x over x to a natural log u over u. Didn't make much progress. So let's not use u equal to 3x. Let's let u equal to the natural log of 3x. Okay, so let's see what happens here. So if I let natural log 3x, what is the derivative of natural log? What's the derivative of natural log? Well, it's just 1 over whatever's inside here. Okay, so 1 over 3x, right? Okay, and then do chain rule times what? Times the derivative of the 3x times the 3. Boom, oh, look at that. This is du is now equal to 1 over x dx. Well, that's what I have here. I have 1 over x dx right there. Nice. Okay, so this was a bust. Okay, so we tried this and it didn't work. Okay, now we're trying, so this is attempt number 1, didn't work. This is attempt number 2. Attempt number 2, and that did work. Okay, so let's see. We've got the integral 1 to 3 of the natural log of u, well, du. That's it. That's nice. Okay, that's it. Okay, well, what's the, nope. It's not even natural log. It's just u. Sorry, I made a mistake. Okay, it's just u because this whole thing up there was u, and the whole thing here is du, so it's just u du. Oh, look at that. Cleans right up. The whole thing makes it really simple. Well, what's the integral of u? Well, that's just u squared over 2. Integrate from 1 to 3, but I can't plug the numbers back in until I put in what was the u. So this is going to be the natural log of 3x, okay, quantity squared over 2. Now I can plug back in the 3 and the 1. So this is going to be the natural log of 3 times 3 is 9. So that's the natural log of 9. Natural log of 9 squared over 2 minus the natural log of, plug in the 1, that's just 3 squared over 2. Okay. And I don't think there's any way to simplify that algebraically. So we could just leave it like that, or we could get an approximation, which is probably more meaningful. Okay, so I'm going to say, well, what's the natural log of 9? 9 natural log. I'm going to square that bad boy and divide it by 2. Okay, I get this. I get 2.413897. 2.413897, right? All right. 2.413889. I just round 8. Okay, minus the natural log of 3 squared over 2. Okay, what's the natural log of 3 squared over 2? 3 natural log squared divided by 2 is going to be 0.603474. 0.603474. And all I have to do is subtract those two numbers. Okay, and I should get an approximate value. Okay, of something. Okay, so 2.413898 minus 0.603474, and it's 1.81. I'll just round to the nearest hundredth. We'll just do 1.81. Okay, it's approximately 1.81. Nice. Great. Okay, example 6. Let's do example 6. Okay, 0, 3. Okay, x square root of x squared plus 3 dx. Okay, nice. Excuse me. Okay, so yeah, I'm gonna rewrite this. 0, 3 x to the x squared plus 3 to the 1/2 power dx. Okay, so what's going to be my u in this case? What's the u? What's u going to be? What's u going to be for Christmas? No. Oh, by the way, Christmas is canceled this year. Don't tell anyone. Okay, don't tell anyone. Christmas is canceled this year. That's why I bought my Christmas present early. Okay, so here's my Christmas present. It's the Mandalorian. It's the Razor Crest. See, it's the Mando set. I bought it already. And I'm going to put it together with my nephew, who's 6 years old, Christmas morning. So, boom. And if he likes it, he gets to take it home with him. If he likes it. If he doesn't like it, it's coming home with me. I can tell you that right now. Okay, but I bought that early. So nobody else could steal it from me. Okay. And then we're going to be up with grandma on her ranch. And there's usually nothing to do but like play in the snow. So I'm like, here, this is what he gets, me and him, from his engineer uncle. Right? Boom, right there. So I don't have kids. I don't have kids that will play Star Wars Legos with me anymore. So I have to steal my sister-in-law's kids. And then they'll play Legos with me. So my kids are like, my kids won't even talk to me at this point. So my son has not spoken to me in 3 days, like literally 3 days. I'm not going to talk first. I'm going to wait and see how long is it going to be. He's 17. So he's 17 and big attitude. So I'm going to wait. I'm going to be like, how long can he go without talking to me? It's a challenge, but I'm not going to be the one to speak first. I'm going to let him do that because he was the last one to speak. Yeah. And it was really rude. He was very rude to me. So rude. It's like Trump. Can I make fun of Trump now that he's out of office? Can I? So rude. I can't get it. Okay. So like him not conceding. How rude could you be? I don't get it. Okay. I'm moving to Antarctica. I'm going to be emperor of the penguins. It's going to be huge. Okay. Anyway, sorry. YouTube's gonna flag this. I know it. They're gonna flag it. I'm like, stop. Okay. Stop it. Okay. Sorry. Okay. So anyway, so yeah, Christmas is canceled. I just want to let you know that, right? Because they just said on the news that basically the whole universe is going under quarantine for the next 60 days. So just be prepared. I'm just letting you know, be prepared. Okay. My kid said the same thing. My kid's like, yeah, Dad, so was Halloween, but we still went out and we still got candy and we still partied. I'm like, I'm not telling you what to do. Okay. I'm just saying that it's coming down from the big guys. They're coming down and it's gonna be canceled. So just if Santa doesn't come, it's because of COVID. Okay, so that's just it. Okay, little sleigh. Again, that's why I went on Amazon. I got Santa doesn't have to come here. He doesn't have to put on his little mask. I already got my Christmas presents. Okay, they already helped Santa out. Okay, I do that every year. I buy my Christmas presents early, so Santa doesn't have to. It's good. So I let Jeff Bezos. He buys them for me. So yeah. Okay. Let's finish up our. Yes, exactly. Jeff Bezos is Santa. Yes, it's right there. I should outside my door. I should put a little chimney, right, and say put the packages here. Right, little cardboard chimney right there. Boom, and say put packages in the chimney. And then the Amazon delivery people, they think like they're Santa. There we go. Boom. He's the anti-Santa. Yeah, there you go. Yeah, he's the reason why there's something called Kwanzaa, right? So, because it's like all like anti-commercialism, like anti-commercialism of the season. Anyway, okay, what's the u going to be here? U is x squared plus 3. Okay. X squared plus 3. And so du is equal to 2x dx. Okay, very similar to what we've seen before. We don't have the 2 though. So we do have the x and we do have the dx. So I can divide by 2, and I get du over 2 is equal to dx. Okay. Okay. Oh, yeah, we'll finish this one up, and then I'll show you in a second what the other thing that Santa brought me today, which was very nice of him. Okay, so du over 2 is equal to dx. Okay, so let's go ahead and look at our u here. So 0 to 3, let's do our u sub. So, oops, this is x. There's an x there. Okay, x dx. So this is going to be u to the 1/2. And then what's the x dx going to become here? What's this thing going to become? That's going to become du over 2. Right? The d over 2 is the x dx. So this becomes du over 2. Okay. So this is just going to be 1/2 u to the 1/2. Right? Okay. 1/2 u to the 1/2. Okay. Now I need to integrate. Okay, du. Now I need to integrate 0, 3. So this is 1/2. I want to add 1 to this. And so what's 1 plus 1/2? It's 1 and 1/2, but I want to make it a fraction. So this is u to the 3/2. Okay, u to the 3/2. And then I divide by 3/2. But that really is multiplying by 2/3. Okay. 0 to 3. So let's clean this up. 2/3 u to the 3/2, 0 to 3. I get 1/3, and then this is u to the 3/2, 3. Sorry, I evaluated from 0 to 3. But again, we have to go back to our original. What was our original? Our original was x squared plus 3, right? X squared, yeah, u was x squared plus 3. So we got to go back to the original before we plug in. X squared plus 3, 3/2. Okay, 0 to 3. Now I can plug in. Now I can plug in. Okay. So this is going to be 1/3 times 3 squared plus 3 to the 3/2 power minus 1/3 times 0 squared plus 3 to the 3/2 power. Okay. And so we get 3 squared plus 3, that's 9 plus 3 is 12. So that's 12 to the 3/2 power over 3 minus, this is going to be 3, 1/3, 3, well, I'll just do 3 to the 3/2 power over 3. Get rid of these parentheses too. Bothering me. Okay, and then we could just plug that in. Okay, so we can plug that into a calculator. And I'll say 12 raised to the 3/2. What is 3/2? 3/2 is 1.5, right? So I could have just raised this to the 1.5 power. It's the same thing. 12 raised to the 1.5 power divided by 3 minus, okay, 3 raised to the 1.5 power divided by 3, okay, equals, all of that will equal 12.12, I'll just say 12.12, 12.12, approximately 12.12. Boom, nice. Okay. Okay, oh, let me show you what else